Okay, cool. We're starting on time. That's a nice change from day one, making some progress. So I said on Monday we would have schedule for the whole semester by Friday, but everything's up there now. So we'll give like a quick overview tour, kind of the main goals, the big highlights that we're trying to hit, and that'll also talk about like what assignments are due, and as it comes up, like how to do them and this kind of stuff. Sound like a plan for today? How's our resolution? Make sure it's 720. Cool. All right, so general structure, the way that my brain kind of organizes Husky CT is kind of folders. I'm like computer guy, old school computer. So everything's a folder. And I'm just going to start with like the module 1 because we're going to do the same thing in module 1, 2, 3, and 4, and then 5 we'll be doing our own thing, kind of make your own. So module 1, the first link is like readings associated with that module, like how to get started and what to watch. And then homework 1 has a link to the homework, and either next class or either Friday or Monday, we can start looking at homework 1 and talking about like how to solve those kind of problems. And then below that link is the actual like submit button, and there you send in a PDF or whatever other kind of, as long as it renders in Husky CT. So PDF is good. Microsoft documents, they're okay. They do render, like they show up, but sometimes they're weird. Images are not great because they have like weird, it'll change the ratios and sometimes flip it left or right. So PDF, doc, or even text, but usually we're doing like handwritten stuff, so usually PDF or something. Or if you're writing any kind of code or making some kind of like analysis, and maybe you want to add that as well. Yeah, so there's homework 1. Quiz 1, there is no quiz 1 yet. We haven't talked about it. We haven't gotten through module 1. So there's the readings that are kind of bringing you back to what we're talking about in that module, and then the place to submit it, but there's no actual content there. What we'll do, so this is September 16th, so probably September 14th, like whatever the class before, or maybe 2 classes before, we're gonna take half an hour and brainstorm like what are questions that should be on this quiz that demonstrate understanding of this kind of content. So I'll ask you what you have. I usually hand out a whole bunch of note cards, and then we write down, I keep track of like what people are thinking, and then build a quiz based on that conversation. So we'll build it together, and then it's a take-home quiz. You go home, plan to spend about half an hour. The goal is that we'll build a question together that takes about 10 minutes to solve, and then give yourself another kind of 10 to 15 minutes of like troubleshooting, like, oh, my internet doesn't work, and oh no, how does this do? And I'll show you how to do that. We'll open up quiz number 0 and do that one together today. Plan. And then project 1. Project 1, this one's different from the other projects, but you'll submit like a document, some kind of document talking about like what do you want to do in this class? Like what's your end goal? Why take this class? What do you want to apply it to? And it's talking about module 5, a loose plan. This is not concrete. Nothing you say in this document you'll be held to. You can you can submit it and then totally throw it out, and then when we get to module 5, you could start from scratch. That happens all the time. And usually that's part of the process. It's like you get to the class, you think you know what you're talking about, and then you learn a little bit, and you're like, I had no idea what I was talking about. And then now you're a whole new person applying new knowledge to this subject. So ideally, things change along the way. If you already know everything there is to know about this class, then I don't know, I guess you could really push yourself, like really challenge yourself and like try to do something new, like some rocket science or computational fluid dynamics derivations or something. Pausing. Questions so far? We're going to do the same thing 4 times, module 1, 2, 3, 4. Yeah.
So when we access the Jupyter notebooks, do we make a copy that we work on for the homework, or does it automatically make a copy for us?
Oh, cool. All right, you're jumping right into Jupyter? Love it. I love Jupyter. I love Python. I love open source work. All right, so we're going to skip ahead. We're traveling to the future. So when we get to Project 2 is... So the whole website is all built with Jupyter notebooks. So Project 2 is a Jupyter notebook, and it's describing like what a 4-bar linkage is, what are constraints on moving parts, and the goal is like you modify this code. You're not writing anything from scratch. And if you do want to write anything from scratch, like you're totally welcome to. With AI tools, like it's become easier to say like, I know roughly that this is possible. Can you give me some code that does this for me? And I'm not testing your coding knowledge, so as long as you're referencing like how you're getting this code, then it's totally fine to say like, this is how I'm analyzing that. And as we go through the project, I'll show some examples, and this is still weeks away. We're out in the future right now, so like hop in your DeLoreans. We'll get back. We have plenty of which one? Plutonium, is it 238? What did they need in the movie to get home, plutonium? I know it was 1.21 gigawatts, but they never specify how much time. That's only how much power you need. But if it's peak power, you could probably get that with a hammer if you only need it for like a nanosecond, right? Like you can make a lot of power in a short amount of time with a capacitor or even just a quick blow. But they never say like how long they need 1.21 gigawatts. No, this reference is like, no smiles. This is all very serious. Time travel is not a laughing matter, Professor Cooper. Anyway, we can get back to the present. So with Jupyter, one thing you can do is like download this notebook, run it in your own like Jupyter environment. But what I did was I partnered with NanoHub at Purdue University, and they created a whole copy of this website, and you can run that on their NanoHub server. And right now I'm logged in because I have my own like NanoHub account, but you'll have to make an account. So I'll show you what happens. I'll log out. Let's close that. So what you'll run into is when you try to launch this tool, it says you have to log in. Again, for me, I created an account. Let's sign in with a different account. You'll come up to this screen where it says choose your sign-in method. Don't use the credentials. Our UConn credentials don't work. Google is totally fine. It works great, pretty seamless. Or you can create an account and use your UConn account. You'll have access to NanoHub for as long as they have funding to run those servers. So I've had a NanoHub account for the last 15 years or so. Like sometime when I was a grad student, I made an account, and I can still go back and find those files. So that I like to have like something where you can always go back and reference your resources without a UConn account. So 2 or 3 years from now. But anyway, once you have that account, So I gotta go back, I gotta sign in because I signed myself out. And it takes a second. Am I redirecting? Let's go. So that one's not working, so let me just click it again. Launch the tool. Thanks, Jimmy. I like the reference too. Why is this not working? Anyway, we don't launch tool, and let's just let it stew on that for a little bit, and then we'll come back. So yeah, there's two ways you can do it. You can either download that notebook, work on it yourself, or load up the NanoHub resource. And once I iron out the bugs, it should be a seamless sort of like click, and now you're in an environment that actually does computations for you. Thanks for bringing up. All right, so we're back to present day. We're just planning the rest of the semester. Rewind. Other questions? Good for now. Overwhelmed with no way to ask a question? No, totally whelmed. Regular amount of whelming. Okay. All right, and last time we started looking at syllabus. Oh, yeah, let's go back to, so we have our calendar. We have due dates. Let's look at the month. So this week, nothing's due, kind of getting our feet wet, getting to know each other. Then on Tuesday, goal is submit quiz number 0. Then on Thursday, so Monday and Wednesday, we'll figure out Jupyter and figure out how to submit homework 0. That'll be our first like Jupyter assignment where we do a little bit of coding, a little bit of reading, but just like figuring out how to get stuff done. So that's our first 2 weeks, and then let's go into September. Then we'll start, after we get through those intro things, like Friday, we'll start looking at homework 1 and start working on that so that the midway through September, we can turn in homework 1, build quiz 1. So homework 0 is, so there's a question from Jimmy. Homework 0 is a Jupyter notebook, and then projects 2, 3, and 4 are Jupyter notebooks. None of this is like you have to memorize like when to flip back and forth. We're going to work on it together. So hopefully the logistics we can get through together and troubleshoot. And then keep going. So now we're in October. Again, kind of going through the same process. Work on a homework, submit the homework. Build the quiz, submit the quiz, work on a project. And then finally in November, we're going to, in that first week of November, try to get through all of the submissions for module. Wait, why are they flipped? I was having like Husky CT, sometimes it's so frustrating to enter dates and flip things. So I think homework 4 and quiz 4 are flipped for some reason. But we'll fix that. That's in the future. Future Ryan can fix that. But anyway, the goal is get through module 4 that week so that the week before Thanksgiving and then the week after Thanksgiving, we can have both of those weeks to build kind of a rough draft and a general kind of approach to our dynamics projects, and then a final draft of what we want to do for dynamics. It's not a big thesis, it's 2 weeks worth of work. So you're not trying to like reinvent general relativity or create like a generalized general relativity. It's sort of like, all right, this is how things work. These are springs, here's gravity. Let me like figure out how I can analyze like something that I know in a dynamics lens. And that's the schedule. We'll submit project 5. We'll take a break for Thanksgiving somehow. Yeah, in future Ryan has to figure this out because it's all weird. Thanksgiving is that week, 24 through 28. So that's, something's weird here. We'll figure it out. I'll figure it out. We'll get there. But anyway, we'll have 2 weeks. The goal is get 2 weeks to work on just individual projects together. Have you looked through syllabus? Yes, no. Anything that is counter to our is there anything that helps the class, like build a learning community so we can actually learn together? What do you think? Let's ask each other, whoever, because if half the people read the syllabus, then the other half can sort of say like, hey, what's on the syllabus? So ask each other, find something that like helps you learn dynamics, and one thing, and then if there's and try to identify anything that's like preventing you from being part of the learning community. Like if there's something like you feel like you're being penalized for trying to learn something, like but anyway, syllabus. What would help the syllabus? What would hurt the syllabus? That's what I'm trying to figure out. Because it's just a website. We can change the website. So what do you think? Or if there's questions. Yeah.
I didn't know if when I submitted it, I went back to your main page, clicked on it, and it said that's like this. Was this supposed to be like students going and copy and work on that? I just wanted to do that. Okay, so this module is the homework, but it doesn't send you to the example lab, so you gotta do it first. Make an account, don't make it through Econ, keep sending it to ticket, make it separate for Econ, and then when you click on this thing, that's how you get one. Whichever one works. I tried using the Utah one, and it just kept I never know when to end and talk about do I include the grip friction of the rope as it's slipping away? Do I include the pie friction against the bag? This already feels like my Photoshop Spider-Man thing that happened. And everything. Okay, so now we're back.
Okay, so I only did a quick survey of like 3 or 4 people, but so far people are like, it's boilerplate, it's what I expect, no questions, no comments. Is there anything different that came up? Yeah.
What if we're not good with Python?
Not good with Python? Then you're in the right place, because you don't have to be good. But you'll get some experience anyway, and then you can still say, I've used Python. So nothing that I tell you to do that is in Python requires like deep knowledge of it. And if you're trying to do something that does require deep knowledge, we can do it together. Like at no point in this course will I critique your coding ability. So if your code is weird and wonky, but it's still giving the right output, it's like, all right, well, it did what I wanted it to do, and because it's a tool that's helping us do some cool physics, like look at physics models. We're not trying to learn the tool and demonstrate that we understand it, which opens up a lot of possibilities because we can just like have fun with it. Cool? All right. So you do have to be able to like open it and at least try it, and we'll learn how to read it together because it is kind of weird. It's like learning a foreign language, but we don't need to know the whole language. We'll just learn enough conversational, like, where's the bathroom? How can I find the library? Cool. All right. So now let's do something fun. Get to know each other. Sound good? At least I think it's fun. You might think there's something wrong with me. All right, so this is, should we do the quiz? No, let's do something that I want to do. Then we'll come back to the quiz. All right, so there's there's an underlying like dogmatism of Newtonian mechanics. What are the 3 laws, Newton's 3 laws? So Newton's 3 laws, what are they? Law of inertia. Okay, which is law of inertia? What is that one? 1, 2, or 3? And what is it? Number 1. How does it work? Like, what is the law of inertia? Sorry? So nothing changes unless there's an outside force, right? Okay. All right. Number 2, what's our second law? Which one? F is ma, yep. The original kind of format was like this external force will create acceleration, will create a change momentum proportional to that object's mass, you know? But the one that we memorize and use all the time is F equals ma. All right, what's the third law? What's our third one? So every force has equal and opposite reaction force. It's a weird U. Okay. Is this, and last time I briefly went over, like there's 4 things that this doesn't cover. Like for a black hole, these kind of things don't apply. If you're traveling near the speed of, if you're a photon traveling speed of light, this doesn't apply. But if you're a neutron hanging out, vibrating, this definitely applies. If you're a proton, this applies. If you're people, this applies. So there are places where the physics get a little weird, but it doesn't change the fact that there's still like laws applying. Does anyone have like fundamental issues with Newton's 3 laws? I mean, we use them a lot, like we keep predicting stuff with them. But have you silently been saying like, I'll do it, but I know it's all wrong? No, usually people don't. At least engineers don't. Okay, so nothing changes without like some kind of external force, and forces only come from other forces, right? So this is a very like old school way of thinking. Was like clockwork. It's like everything's kind of moving because something else is moving it. If every action is due to some reaction, every reaction is due to some action, can you still have free will in that Newtonian universe? Like, can you still make a free choice, or is it just, are you just following Newton's laws? That's my question to you. So take a minute, talk to somebody else. You can try to convince them that they are wrong if you want, or you can both like have an echo chamber about how like, yeah, free will, it's free will, or no, free will is, it's a myth, sheeple, wake up. I don't know. But take a minute, what do you think? Free will, yes, no?
Actually knowing about whether our actions are predestined because of sets that reaction that are created by that's like, is it math that's letting me think this right now, or am I outside of the math system? Oh, you're thinking about it before. You're thinking about how it affects me. I'm thinking about, are we all cells? Everything we know about cells is that they do everything because of physics, right? Biology is taught us that energy is literally right? That's not something they consciously do. They consciously control it, so the physics in it is just kind of happens, right? Because chemistry is dictated, but that's not what if it doesn't correlate, then do so because of it, but that's not really the point. The main point is it does it, but it doesn't have any control over it. It just kind of happens. Right? So on a larger scale, are we able to do more than the cell can do, or are we also want is that because we haven't willed it, or is that because neurologically the company has dictated that we want to make some social that we don't look at enough? So we're also smart enough because of our mental brains to say we know exactly what to do to fix the problems that we don't like about it. Is the choice predestined? Is that predestined? If I were to have one person go through their entire life and it would be the exact same, everything in the universe would be the exact same. If you died right now, you would just reset your world, everything would be the exact same. Right? That's why we're trying to create that divide, right? As fans, better, as much as possible, right? This is a question of how do we, not very it's process that I have all access to once they become smart enough, they're just like, like you guys can fly off the stage. But that's the point, that's the universe, right? We have this program, it didn't really matter. We're just combinations to make her language. She's Truman. Hello, Truman. It's so nice to meet you.
All right, so let's do quick survey. Here. All right, so without any, there's this initial survey is just with no explanation. You're either raising your hand yes or no, and then if you're really unsure, then you're the maybe. So quick survey, who says free will? Yes, like free will still has to exist. We'll go, all right, this looks like, sorry? This one's yes or no, so this is a yes, free will exists. So this looks like 70, 75% of the class. We'll say 75. All right, who says no? Free, like Newton's laws are there because Newton's laws work, and therefore free will can't exist. Like more like 5%. I'll give it 5. I'll give it 7%. 7%. And then who's in the, like, you just blew my mind right now. I don't even know which way is up, like the maybe camp. Also similar, 7%. Actually, maybe more, 10%. We'll go 10. Let's say 10%. All right. Okay, so now let's open the floor for yes. Let's start with yes. Like why? Let's start with yes. We'll go left to right. Yep.
In our discussion, we said that even though you can have free will, you can still have rulings in there.
Okay.
You have the will to choose it.
Okay.
Like you could murder someone right now.
Okay. Yeah. That went dark quick. Yeah. You choose not to.
Also, you don't want to deal with the consequences of being murdered back, which is part of it.
Okay. So there are like societal norms. There are like forcing factors. Okay. Yeah. So there's like not just Newton's rules, but Newton's rules might also within that there's like society rules, like things that are forcing your hand to do certain things. But you can still choose. So, and this is I asked a couple of people this question. When your brain is physically choosing something, like when it's like something's happening in there, it's kind of neuron pathways. Are those neuron pathways not subject to physics? Like it's electrical impulses kind of traveling through your brain. Can that happen without? Like, because if it's that, it's like kind of V equals IR, like it's an electrical circuit. Maybe there's some dynamics involved, but for the most part, we have like very governed rules. It might be complicated, but it's governed. So can that happen out? Can you make a choice without something physical happening? No, I see some no's. I'm not trying to rebut in the yes, but I just wanted to clarify that. Like, do we think that there's a choice that can be made without physics? That was my question there. Okay, so then what else? What else did we say about yes? There has to be free will. Yeah. You could just throw your pencil. Can the pencil choose not to fall?
No, it still follows.
Pencil has to, okay.
It's not going to get to the mark on its own.
Okay.
I'm using my own free will for forcing it.
So you think you are the unmoved mover, that you can,
I mean, in the scenario, sure.
you can create change. You can be the outside force that is not forced upon. Is that
In the system of the arc.
in this system? Yeah. You can create that arc, but not actually be affected by it. What do we think? Yes? Maybe. What else? Were there other? So there, it's very evidential of like, I see free choices all the time. People do stuff that's crazy that I don't understand. There's no way that this stuff could have been predicted. President Trump, nobody saw that coming. Okay, so what about the no camp? Who says no? Like, we can't. What is this for? This is for science.
So, all things are made out of matter, yeah?
All things are matter, yep.
And matter itself is inanimate. Ignoring stuff like quantum physics and all that. If you throw a ball
Yeah.
in a certain way, it will move the same way.
Yep.
If you throw it 1,000 times, it will move the same way 1,000 times.
Yep.
So, because we are all made of matter, all our thoughts, all our consciousness, it comes from brain chemistry.
Yep. And chemistry
because
is
brain
a
chemistry
predictable
is
thing.
itself moving in response to other previous acts of brain chemistry, which itself is moving because of previous motions made by other inanimate matter.
Okay.
Could you not then say that that brain chemistry, the brain chemistry that determines what we do, the brain chemistry that determines what choices we make,
Yep.
could you not then say that that brain chemistry occurred as a result of a collision of a collision of a collision going all the way back to the Big Bang? Because of that, can you not then say that that exact brain chemistry that triggered that decision you made to buy that latte or whatever,
Yep.
that brain chemistry is a result of all of those collisions that had no input from free will going all the way back?
Yeah.
Could
And
you
so
not then say that that decision was inevitable from the very beginning of the universe?
that's, and like the case that you're kind of making of like, once everything was set in motion, whether we call it the Big Bang or we kind of freeze everything in time and measure, like that was the original goal of physics, was the idea that if I knew where every particle in the universe is at a given moment, and I know how fast it's moving, everything's predictable from there. Like there's nothing that it becomes an open book that you can kind of flip forward and backward in time. And this is still, like, we try to kind of work around it sometimes as engineers and physicists, but at the end of the day, there is still that dogmatism of like everything could be traced back to the Big Bang. Is like, that's where this brain came from, that's where this person came from. Yeah.
There's also a built-in like chaos though in the universe.
Okay. Ooh. All right. Chaos theory.
Probability, but nothing is inevitable.
Oh, okay. So you're back in yes camp? Yes free will?
I'm not really either.
Oh, okay. The maybe camp.
You can trace
That's
that,
fine. Yep.
But you can't go forward. You can only say probably.
So have you heard of or kind of thought about chaos theory before? Okay. Someone give us what's your quick spin on chaos theory?
I would just say that chaotic things are things that are chaotic are indistinguishable from complex enough systems.
They can be, sometimes it's complex, yeah, okay.
So when you say chaos, I can just say that's just something that is so complex that you can't quite wrap your head around.
Let's see if my video still works. Okay, let's see. Oh no, is it broken? Oh, here we go. All right, so here are, I forget if it's 10 or 100 pendulums, but we'll find out in a second. They all like start in the general same configuration, but by the end of the simulation, they all create their own path. Like literally their own path, right? This is kind of chaos in motion. Are these pendulums making choices? No? Why not a choice? Why isn't it a choice? They're all doing something different. Is it a choice? I saw some head shakes. Nobody said like, yes, this is that pendulum blue. This blue pendulum is different than that red pendulum because of like, I don't know, they went to private school. So chaos theory is like, it's kind of this double-edged sword where people point to it and say like, look, with simple physics, lots of complicated things can happen, so free will could be there. But the other side of it is that every step in time is the only thing that these pendulums are doing, because it's a simulation, is following F equals ma. They're not doing anything else. So there's definitely no choice here in this simulation. I'm not saying like this is a metaphor for your life. It's just, this is a very sandbox simulation of pendulums bouncing around in circles. Taylor Swift can predict my movements? I don't know. How good is she at physics? Do we have more no's? Or we had a maybe camp. Were there more maybes that want to convince everyone they should be in the maybe camp? All right, let's take one more minute to talk about it, and then we're going to do we'll do a final survey on this, and then I won't keep like beating a dead horse about how you have no free will, you're all just living in a simulation sort of discussion. But I'll check in, and then we'll do one more survey.
Most people use it as too much to bear. Right, like there's no free will. Morals are based on what we in a lot of states, right? There's a biological reason. There's a biological reason. There's a moral reason. It's kind of up to who likes it. No, the main point was like free will. The one side is morals, and I feel like those morals are way too subjective. It's more just really yeah, I think they're separate. I think they correlate, but they're not I mean, we kill ants all the time. We consider that for soul to be. So what if it's like the once you go on the scale? Does that mean there is a small enough point to where physics doesn't apply and therefore free will is the most available? So you go to like the quantum scale, smaller than the entire brain, long as like fucking microscopic, and free will is in its purest essence. Someone said earlier, math is not objective, right? It's our understanding of how the universe works. And everything we learn in school is what we can concretely believe, right? And so we prove to ourselves the confirmation that it works. But every time we go to talk to someone that researches math, they're like, yeah, this shit falls apart. I'm trying to research this, and it disproves everything I've learned in the last 15 years. So it's like, that is our understanding of the universe in but the second we try to apply new material to it, it challenges everything we already know. And I feel like the same thing applies. Because we reinforce everything that we can concretely say. Like, I can choose right now to slap under the and everyone will randomly choose if they want to slap me in the face based on their chances, right? But if I do this trial, I could probably advertise statistically on who's most likely. And if I run it 100 more times, I'll probably see that the numbers but then you can fall like computer randomness isn't right? It's impossible to make a computer actually random. So we base it on milliseconds from 1970, and then we add complex mathematical parts to make it look random. And then real randomness is like, we can't prove it because it's on a scale so small and add performance change. That's the 10%. We can see and prove the randomness in the computer. That's why we're like, oh, randomness, quantifiable. The actual randomness may or may not be a complex set of equations that we don't understand. So, like, I lean hard towards the yes part just because I'm human, but like, I could very well see why we are just cascade. She's a machine. She was working on that homework all day. Oh God, give me homework. Do it 5 days.
Okay, so what is W stream? Is that okay? Oh, good. Oh, winning. All right, W is good. I'm like, is something wrong? I thought it was like wonky. All right, W. There we go. Okay, so let's do one final survey for free will. So who's still in the yes camp or change to the yes camp? There's maybe. It feels more like 60 now. Like I think it went down. Did it? I think so. That's 60%. Who's in the no camp? Of you were maybe no before, maybe now no. Is it less? Maybe. At least for people that are. There's less people raising hands in the no free will camp. Oh, no free will. That's okay. Yeah, I don't know. I feel like it went down. All right, what about the maybe camp? This went up. This definitely went up. So now we're staring at maybe 20%. I think 20% now. So we had a drop in no's, a drop in yeses, and an increase in maybes. So glad we made things more clear with this discussion. Are we out of time? Oh, we're out of time. Okay. Is that it? We're out? Yeah, that's it. All right. Thanks a lot. And next time we'll do some physics.